How does asynchronous communication work? Have you ever wondered how information travels between devices without needing to be perfectly in sync? Let's break down the fascinating world of asynchronous communication and how it connects to asynchronous circuit design, emerging computing technologies, and neuromorphic computing. Asynchronous communication is a method of exchanging data where information is sent intermittently. Unlike synchronous communication, which requires both sender and receiver to operate on the same clock signal, asynchronous communication allows for flexibility. This means data can be sent and received at different times, making it useful in situations where an immediate response is not necessary. At its core, asynchronous communication sends data one unit at a time. This could be 1 byte or 1 character per transmission. Each unit is framed by special bits known as start and stop bits. These bits signal the beginning and end of the data unit. They help the receiving device know when valid data starts and stops, distinguishing it from noise or irrelevant signals. Thanks to this framing, the receiver can interpret the data correctly, even if the clocks of the sender and receiver are not perfectly aligned. In practical terms, this means that data can be transmitted with variable timing intervals. The absence of a continuous clock signal allows the transmitter and receiver to operate independently. This simplifies hardware requirements and increases flexibility in communication systems. When we look at the physical layer, asynchronous serial communication involves sending code words, such as bytes or American Standard, code for information interchange characters, framed by start and stop bits. There may also be variable length spaces between these code words. This character-oriented approach is common in older modem communications and other serial interfaces. At higher protocol layers, asynchronous communication can take the form of statistical multiplexing. This is where data is sent in packets instead of a continuous stream. For instance, asynchronous transfer mode networks use packets called cells to transfer data asynchronously. These packets may be encapsulated within frames that include synchronization sequences to help identify frame boundaries, even though the underlying transmission remains asynchronous. Now, how does this relate to emerging computing technologies, particularly neuromorphic computing and asynchronous circuit design? Asynchronous circuits operate without a global clock, much like asynchronous communication. This allows components to process and transmit data independently and only when they are ready. This design can lead to lower power consumption and reduced electromagnetic interference, which are particularly beneficial in neuromorphic systems that mimic brain-like processing. In summary, asynchronous communication works by sending data units framed by start and stop bits without needing synchronized clocks between sender and receiver. This allows for flexible and intermittent data exchange, suitable for various applications, from traditional serial communication to modern packet-switched networks and emerging asynchronous circuit designs in neuromorphic computing.